All right, welcome to video lesson number 3, and this is going to cover something called mass-to-mass stoichiometry. Now this is the largest stoichiometry problem that you're going to encounter in this chapter, and it is one that is, well, 3 steps. If you're thinking back to the flowchart that I presented to you on last couple of video lessons, we'll start with that. When you're doing mass-to-mass stoichiometry, you're going to be given the mass of one substance in a problem, and with the chemical reaction provided and a periodic table, you'll be able to calculate the molar mass of that substance to convert to moles, use the mole-to-mole ratio from the balance reaction to convert from moles of something you know to moles of something you're trying to find, and finally finish the question off with solving for mass of substance B. Another way of putting it is you're going to take a mass and convert to moles, go from moles to moles, and finally get away from moles and go back to mass. This is going to require 2 conversions that are molar mass steps, and it's the first conversion and the last conversion, and then the middle conversion is the mole ratio step. So once again, I always encourage my students to underline what they have. After reading the problem, you have 25 grams of H2. That's this substance right here. And I'm looking for grams of NH3, which is this substance over here on the end. And the only one that I'm not using, and so I can cross it out of my problem, is the N2. I really don't care about the N2. Remember, only thing that you're worried about is what you have and what you're trying to find. In stoichiometry, there's really only 2 things, known and unknown. All the rest is extra information. Now I'm going to begin setting up this problem with the number that I have. I begin with 25.0 grams of H2 over 1, and I'm going to multiply. Remember, this first step is going from mass to mole. So I'm going to use the molar mass of that substance. So I go grams of H2 on the bottom, moles of H2 on the top, and 1 mole of H2 is equal to 2.02 grams. Now as a reminder, molar mass must be added up off the periodic table. So H, which is 1.01, plus 1.01 is 2.02. Now this first step converts from mass to moles. The next step is going to take me from moles of that H2 to moles of the NH3. Another reminder that this is the only step in which the substance in the top and the bottom are different. Molar mass always has H2 and H2, grams and moles. The last one will always have the same molecules, but this one has different molecules. This is the only step that has different molecules. It's also the only step which incorporates the coefficients from the balanced chemical reaction. So the number out in front of the NH3 is 2, so I'm going to put that right here on top in the numerator as a 2. Now the number in front of the H2 is a 3, so I'm going to put that down here for moles of H2. So then the last thing I need to do is convert from moles of NH3 to grams of NH3, once again using the molar mass, but now the molar mass of the new substance, NH3. Now if you remember from a previous video lesson, I did this one before, it's 17.04 grams for every 1 mole. Students always ask me, especially when they're struggling or developing this skill, is how do I know where to put the number? How do I know that grams goes on top and not on the bottom? And the answer I give them is, well, moles, when in a molar mass, always is equal to 1. So 1 mole. The grams has to be from the periodic table. So if you set up your units to cancel out, like you should, you put the numbers where the grams are, and you put 1 where the moles are. Same with over here. 1 mole is equal to 2.02 grams. But we want grams on the bottom because we want grams to cancel here, but we want grams on the top because we want grams to be what you're finished with in the end. With that being said, you punch this into your calculator and you get an answer of 141 grams of NH3.
Next, I'm going to do a practice problem for you from our notes. We've got 25.6 grams of HCl and plenty or excess sodium metal. And we're going to mix those together and we're going to make a single displacement reaction, and hydrogen gas is going to be produced in this reaction. So let's first start by writing this reaction, then we'll balance it. So we're going to put the sodium as a solid plus HCl as an aqueous solution, and then that is going to equal the H2 gas, which is going to be produced from the single displacement, and then sodium chloride aqueous. Now this one's a fairly easy balance. I've got 2 hydrogens here and I've only got 1 here. So I just need to double the hydrogen, and when I double the hydrogen, I double the chlorine. So I go back over here, double the chlorine. Now when I double the chlorine, I also double the sodium. So I go back to the original side and double the sodium. So my balanced chemical reaction is 2 to 2 to 1 to 2. Now this balanced chemical reaction is really important because we're going to use that in the middle step of this stoichiometry process. This is the mole to mole step, which I showed you on the last practice problem. Next, let's write down what we know. Let's write down our plan. Let's see what we're going to do. We're going to start with 25 grams of HCl. So we're going to start with mass of substance A, and we're going to convert to moles of substance A, where A is the substance you know. That's what you were given. In this case, it's the HCl. Now, we're going to use the mole-to-mole ratio to convert to moles of substance B. And then finally, using a second molar mass for that substance that we're trying to find, in this case, it's hydrogen gas, we're going to find the mass, or grams, of substance B. And that's our plan. We're going to go from mass to moles to mass, using a molar mass step, a mole-to-mole step, and a second molar mass step. So you have this little blank template in your notes, and it's going to help you in setting up your 3-step stoichiometry process. Now we first want to begin over here on the left with what we know, which was 25.6 grams of HCl over 1. Now that goes in the top and 1 goes in the bottom. Next, we're going to use the molar mass of HCl to figure out how many moles there are in the 25.6 grams of HCl. So we want grams of HCl to go down here and moles of HCl to go on the top. Now it's 1 mole is equal to the molar mass, which is 1.01 plus 35.45. So it's 36.46 grams per mole. Now the grams will cancel. Next, we want to go moles of HCl on the bottom because we want moles of HCl to cancel moles of HCl. So we need those to be opposite. And what we're converting to is H2 gas. We're trying to get to H2 because eventually we want to solve for grams of H2, so we've got to convert to moles before we can get to grams. From the balanced chemical reaction, if you've got it written down, just go back and look, it was 2 moles of HCl for every 1 mole of H2. This is the mole-to-mole step. This is the step that actually makes stoichiometry stoichiometry. Anything else is just a unit conversion. But stoichiometry requires a mole-to-mole step, which converts from moles of something you know to moles of something that you're looking for. Finally, we need to set up moles of H2 on the bottom because we're going to use the molar mass of H2 to convert to grams of H2. And 1 mole of H2 is 1.01 plus 1.01, or 2.02. Now that we've got all of these set up, the units are all going to match up and cancel, and the only unit that's not canceling out is grams of H2, which is good because that's what we're trying to find. Now if I punch this into my calculator, I get an answer of 0.709 grams of H2. And we want the significant figures in our answer to match the significant figures of the only number that's measured in this problem, which was the original number, 25.6 grams. So in summary, all stoichiometry problems that start with mass use mass to get to moles, then you do the mole-to-mole step in step 2, and then the mole-to-gram step in step 3. And your answer should have the same number of significant figures as the first number in the problem because it's the only measured value. Now, you might have problems with more than one measured value. Your answer should reflect the precision of the least precise number of the measured value in your problem.
I'm going to finish off this video lesson by showing this flowchart once again and these useful things to remember. Remember, you're always going to be starting with either mass or moles of a substance. And you're going to be either asked for mass or moles of a substance. In red here, I have listed the conversions that you use at what step. Converting from mass to moles, you use the molar mass, which is added from the periodic table. Converting from moles to moles, you use the mole ratio, which you use as the balanced chemical reaction. And going from moles back to mass, you use molar mass again, but of a different substance than you used in part A. Again, add that from the periodic table. The useful things to remember: make sure you have a balanced reaction. If it's unbalanced, you have to balance it first. Make sure that you're only comparing 2 parts of a reaction. Fully label your units so that you can show all your work. Meaning, don't just say moles or don't just say grams, but say grams of what, moles of what. Finally, if you have moles, you can always convert to grams using the molar mass of the periodic table. And I've decided to add this final thing to remember. Only use coefficients for the mole ratio step. Never use them when using or calculating the molar mass. That concludes this third video lesson. Thanks for listening.